Hello everyone, long time no see. Today I'm gonna record a video on clustering with DBSCAN. So DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. What is noise? Outliers. So in class we talked about the z-score, the IQR, also method for outlier detection and correction by removal. And today we're going to see how we can use DBSCAN for also outlier elimination. In general, when we're working with clustering, we'll be either using methods like k-means clustering that will be focused on the spherical, we call it, or convex data. So in this case, for example, as you can see in database 1, you can easily see the three clusters by eye, of course. And both DBSCAN and k-means could be very good and efficient methods to identify the clusters. However, k-means will be drawing, for example, lines through the plane to show that this is a cluster, this is another cluster, and that's another cluster. This also gonna be an efficient shape of a cluster, but only for DBSCAN, but not k-means. As I said in here earlier, k-means, you need to think of it as a straight line slicer. So if you can slice here a straight line and slice here another straight line, then you will have three different clusters in three different areas of the plane. However, in database 2, for example, if you want to identify this as a cluster, then probably you could draw a plane over here, a line over here, and then you can't draw another line to separate these two together, but you could probably halfway through. Now, looking into this, the database 3, as you can see here, the complexity goes up, and you can't slice with a straight line from beginning to end in the plane, and therefore, if you use k-means clustering, the code will work. It's not that the code won't work, it will work. And for example, if you want, you can just draw a line here. This is first cluster. This another line here, this second, this will be third. It will cluster the data, but I think the best way to cluster this data is looks to be by eye. I can see that this is one line, so one cluster this is one cluster, and that would be here, this would be here another cluster, and then in the center will be also another cluster. So that would be the most perfect way of a clustering. So think of k-means clustering is a way of a clustering as using spherical data, and I'm going to talk about k-means clustering in another video and explain what does it mean, spherical data. What is spherical data and why with k-means clustering we only afford or able to actually slice the plane into straight lines. So density clustering more or less identify these points that are very dense and close to one another. And the way that it does that is through identifying two main parameters. The first parameter is the epsilon, and this defines the radius of the neighborhood around the data. So if the distance between 2 points is less than or equal the epsilon, then these 2 points are very close to each other, isn't it? And then they are considered as core points. In some explanations, they refer to them as neighboring points or neighboring points, but we also refer to them as core points. So the distance measure that is used for the epsilon, the default distance measure, I'm sorry, this is not mentioned here in my notes, but the distance measure here is used the distance measure that is used is the Euclidean distance, which is a distance measure for continuous data. So keep this in mind, we're going to come back to this point in a bit. So this is for continuous data that measure the distance between 2 points, which is basically a linear line. Then the second key parameter, other than the epsilon, is the minimum points. With the minimum points, then within this radius, what is the minimum acceptable points? Usually, the minimum acceptable points should be greater than or equal don't forget the equal, to the number of dimensions. What is a dimension? A dimension is also, we refer to it as a variable, but in clustering and data analytics, we call each variable, or we refer to each variable as a dimension, especially if we consider it as a vector or a vector. So minimum points should be the number of the minimum, at least the number of variables plus 1, equal or greater than. All right. However, in some scholars kind of tolerate the distance being 3 minimum. I say, to be safe, at least let it be d plus 1, the dimensions plus 1, and see what happens. I mean, you have to get into a trial. All right, how does it work? So how does that work? So as I said earlier, there's something we call it neighboring points or core points. So for example, if you take a look at this illustration, you will find out that all the red points in this area are very close to one another. So within the radius, that's the point. They are within the radius. So you can see so many circles. I believe that this circle that I am right now pointing out to is actually the circle that is the radius for point A. And within this radius, there is minimum 1, 2, and 3 points. So this hopefully is a very good illustration that you can see that this considered a core point, because within the radius there are 3 points inside that radius. This point, this red point also, you will find out, for example, there's only 2, and then there's this point also within its radius. Now it is yellow for a reason, but if you can take a look here, 1, 2, 3. Over here also, there's also another radius. There's this point, and there's 1, 2, and 3, and so on. So now these are the core points. So the first step is to identify these core points by drawing a radius around arbitrary, randomly selected point for the algorithm. Then how do we form a cluster? We form a cluster by also arbitrarily or randomly selecting, the algorithm will do that, will select randomly one of these core points, and then it will start expanding. So this is the essence. So with core points, they expand the cluster. So this point is a point that satisfies the following: that the numbers, the minimum number of points within the epsilon neighborhood is satisfied, and if the count meets or exceeds this count, then this point will be a core point. So this is how we form a cluster. Now, the density connectivity, 2 points A and B, for example, as you can see here. So these 2 points A and B, they are density connected if there exists a chain of points where each point is within the epsilon radius of the next, and at least one point in the chain is a core point. So this point is still going to be a density connection. Now, how do you also take a look at these points? You also think of these yellow points as borders or bordering points. I'm sorry, it's not written here, but these, we call them also border points. So these yellow points are border points. Why? Because when this point when its turn has come in the algorithm, and we drew the radius here, we found out that it does not satisfy the minimum number of points, and it has only 1 point in its radius, and therefore, because it has 1 point in its radius, it is considered a border. Yeah. However, this red point, it satisfies 3, 1, 2, and 3. Do you see that? But the yellow point itself, When we drew this radius, or over here, when we drew this radius, for example, there was only 1 point, and it seems like the minimum number of points in this algorithm and this illustration is 2 points. So it did not satisfy that, and therefore it is a border point. Now this border point could be part of the cluster or could be not. What does that mean? Well, I meant when I said earlier that the red points, which are the core points, they expand the cluster, yeah? But these yellow points don't have the same power. They can just be either part of the cluster or not part of the cluster. So this, do you understand that? So these points expand the cluster, but this point cannot expand the cluster. It's just either are you going to be part of the cluster or aren't you going to be part of the cluster, and this is also this distance based as explained earlier. Now label noise points. As you can see here, the n, point, doesn't have in its radius any point, no core point. Do you see here? This guy has at least one core point in their radius. In this case, they could belong to the cluster. Do you see that? This also point is a border point that qualifies to join the cluster. Why? Because it has in its radius, within its radius, a core point. This point, on the other hand, it's also considered a neighbor point, but it's a far away neighbor, and in fact, within its radius, there is no point, no core point within the radius, at least one core point. There isn't such a thing, and therefore it is labeled as noise. Noise means outlier. Do you understand now? So the red points, the core points, expand the cluster. The bordering points that has at least one core point within its border, its radius, either belong or not belong and be considered a noise. I feel this is a very easy algorithm. So let's get started with the. Also, before I get started with the with the code, I want to say that since the distance that is used, the default distance that is used in DBSCAN, considered Euclidean distance, and this distance is used for only continuous variables. If your data set consists of mixed variables, categorical and numeric, then you need to incorporate what we call it an appropriate distance measure. I will show you one of the distance measures that is widely used with DBSCAN, and it's called the goer's distance. That is used along with DBSCAN when we have mixed variables. So I have the code also for that in some of my next videos. Now, before we jump into the code, let me just explain a little bit about evaluation metrics for the DBSCAN. Usually we use the silhouette score, and this silhouette score is also used for the k-means clustering indeed. So with this score, it ranges between -1 and 1. A score nearby 1 denotes the best meaning of the data, like the best consistency of the data. When it is around 0, there is a little bit of overlapping, and when it's -1, it's really horrible, and maybe this technique for clustering is not good for the data. Or you need to find out which variables could be clustered together and which variables should let go. So you have big data and you have, like, for example, 7 variables or 5 variables, and you want to cluster to find meaning in the data. That doesn't mean you need to use, it's not a must that you use all 5 or all 7 variables if they are going to lead to an evaluation metric, for example, the silhouette score that is being in the negative. Now, there are other evaluation metrics. One of them is what we call it the AR range. And I know this range is usually It's a kind of it's kind of a manipulation of the data in such a way that even though clustering is considered an unsupervised machine learning, they kind of have like actual labels of the clusters, because the clusters eventually the output are labels, and then they already know by eye that this is labeled as such. So what's the what's the point then? So this is purely for academic purposes, so that I can, for example, if I wanted to, for example, give you a quiz or an assignment, and I can use this kind of already a clustered data or simulated data, and then we can use this method. So I'm gonna just use the silhouette method for my teaching, because this is what really used in unsupervised, purely real life unsupervised clustering method. I don't want to make the video longer, so I'm going to see you in the next video where we're going to start with the code.